Let us evaluate an integral that contains a rational fraction and that it contains a quadratic factor, specifically one that has a non-repeated irreducible factors. For this, whenever you encounter something like this, the general formula would be the integral of p of x. P of x here represents our numerator over n of x, wherein n of x here represents our non-repeated irreducible factor in here. By this, it can be equated to the integral of a constant, let's say something like a sub 1, and multiply this by the derivative of n sub x, wherein just the derivative of our function here, I mean not the function, all over n of x plus another constant, let's say something like a sub 2 over n of x. Whenever you encounter something like this would be the general formula or the form of this. And so, by that, we can now make this a decomposition of a partial fraction. But we can first put our normal term here, which is simply just x plus 3, by ignoring first the integral and the dx. For this, in order to simplify, this would be just a, which represents a constant, over x plus 3. Now, this is the partial decomposition fraction for just x plus 3. And add now the partial decomposition fraction of this, which is based on this formula, plus a sub 1 here. Let us represent this now as b, and let us multiply it by the derivative of n of x, which is this one. The derivative of x squared would be 2x. The derivative of x is simply 1. And the derivative of 2 is 0. So no need to put it. All over n of x, which is also this one, which is x squared plus x plus 2. Plus this one, which is a sub 2. Let's substitute a sub 2 as a constant c, all over n of x again. Now that we have this form, the next step would be to equate this to our problem. For that, this would be a over x plus 3 plus the rest first, and equate this to our problem. But let us remove the integral and the express. We can just put that later on. Now that we have this, our next step would be to get rid of the denominator in here, and by doing that, multiply both sides by its denominator. For that, it would be x plus 3 multiplied by x squared plus x plus 2, and multiply it by this, and copy what's left in here, which is simply the numerator. And now, multiply this value on this, focusing on the first part, this multiplied by a over x plus 3. You can actually see here that x plus 3 would cancel by this, And what you're left with here is a multiplied by x squared plus x plus 2. Now that you have this, next up would be multiplying this into the second part. By that, by analyzing it, you can actually see here and again that x squared plus x plus 2 would cancel each other out, which leaves you with b multiplied by 2x plus 1 and multiply it by x plus 3. And for the third part, which is c over x squared plus x plus 2 multiplied by this again, you can see here again that these two will cancel each other out, which leaves you with a value of c multiplied by x plus 3. And just copy the rest here again. Now that we have this, what we're going to do here now would be to get rid or find the value of either of this variable. And to do that, we must get our normal factor or in the denominator, which is only x plus 3, because x squared plus x plus 2 is a special case. So just use the normal factor in here, or the normal term, and equate this to 0. And putting 3 outside the integral, x here now would be equal to negative 3. And by that, we can now substitute all x values here as negative 3. By that, this would be x squared would be negative 3 squared plus negative 3 plus 2 and for this b, wait, now that I think about it, you can see here negative 3 plus 3 would be equal to 0, and so anything that is multiplied by 0 is all 0. So b now here would be equal to 0. So we can just get rid of this and focus on the c now, which is c multiplied by negative 3 plus 3 again. We can see here negative 3 plus 3 would also equal to 0. So just erase that once again. And now what you're left with here would be this value. And substituting negative 3 in x here. And now let us simplify it. Negative 3 squared would be equal to positive 9 minus 3 plus 2. 9 minus 3 would be 6, plus 2 would be 8. So this would be 8 multiplied by a. And negative 3 multiplied squared, would be equal to positive 9. 12 multiplied by negative 3 would be equal to negative 36 minus 20. Combining all of this, you should have an answer of 16. And by dividing both sides by 8, you would have a value of a equal to 2. Now that we have our first variable here, since what we're dealing with here next for our second term is an irreducible factor, we cannot simply equate this to x and find and substitute again. It simply cannot be. And what we're actually going to do here is to first multiply these two together. So let us just rewrite this. But first, we can now put a here as 2. So a here would be equal to 2 plus b, and combining these two values together, you would have a value of 2x squared plus 7x plus 3 plus c multiplied by x plus 3 equal to 8x squared plus 12x minus 20. And now, next step would be to distribute all of the outer into their respected parentheses. This would be 2x squared plus 2x plus 4 plus this one, which is b multiplied by 2x squared. So let's put this as 2bx squared plus 7bx plus 3b, and for this it would be plus cx plus 3c and now that we have all of these values here, what we're going to do here would be to isolate all values that have an x squared. This should be the first, the second one, and the third one in here, and just equate these to each other. So this would be 4x squared, which is equal to, just copy the coefficients, which is 2 plus the coefficient of this would be 2 multiplied by b, and it is equal to 8. And now, by isolating b, this would be 2b equal to 8 minus 2, which is 6. And now, b here now is equal to 3. And now that we have found the value of b here, we can first substitute all values of b. Note that b, by substituting this should be equal to 3. And so, 2 multiplied by 3 would be 6, which makes this 6x squared. 7 multiplied by 3 would be equal to 21, which makes this equal to 21x. And 3 multiplied by 3 would be equal to 9, which makes this equal to simply 9. Now that we have this, our last variable here is simply c. And since this is connected to x, just focus on getting all values that has an x here, or has a variable of x. This would be 2x, 21x, cx, and d equal to 12x. Putting this as team x, this would be 2 plus 21 plus c equal to 12. Just copy the coefficients of all the variables that has an x once again. And by isolating c, this would be equal to 12 minus 2 minus 21, thus making c here equal to negative 11. And now, we all have our variable values. Let me just rewrite our other form here again. Note that our other form here, as we had written earlier, is equal to a over x plus 3 plus b multiplied by the derivative of this one, which is 2x plus 1 all over this term again, which is x squared plus x plus 2 plus c over this term, which is x squared plus x plus 2 again. Now that we have this, we can now put the integral and the dx in here. This is the same as this, just a reminder of you. And since we already have our variable values, let us now substitute it in here. A here is equal to 2. B here would be equal to 3. And C here would be equal to negative 11. We can split this integral into 1, 2, and 3 parts for simplification. Now that we are in this situation now, we can put all constant first outside the integral. So put 2 outside, put 3 outside, and put negative 11 outside the integral. This would be 2 integral of dx, or let's say put it at 1 over x plus 3 first, multiplied by dx, plus 3 integral of 2x plus 1 over this. And since this is negative, it would be minus 11 integral of 1 over x squared plus x plus 2. Now, how can we integrate this? Let us first let us use u substitution. Focus on the first part. This should be 2 multiplied by the integral of 1 over x plus 3 of dx. Let us use u substitution in here. Let u here be the denominator, which is x plus 3. And taking the derivative, whenever you use u substitution, take the derivative next. Derivative of x is simply 1. The derivative of 3 is 0. And since this is respect to x, multiply this by dx. And so, du here would be equal to simply dx. By substituting that, it would be the integral of 1 over u multiplied by dx here would be equal to du. And why did we do this? Because we have the formula of logarithm, wherein the integral of du over u would be equal to the natural log of absolute value of u plus c. Note that we can simply multiply du by 1, which makes this du over u. And it follows the formula here. And by that, the integral of du over u, according to the formula, would be equal to ln of absolute value of u. And don't forget, and don't put plus c yet because we have other parts of integral to solve. And by the final answer, put u back first into its original form, which is equal to x plus 3. And our integral for this first part would be equal to 2 ln 2 natural log of absolute value of x plus 3. This is the answer for the first part. For the second part, this would be 3 multiplied by the integral of this again. Once again, let us use u substitution here. Let u here be the denominator once again. which is equal to x squared plus x plus 2. And the derivative of this would be equal to 2x plus 1, and multiply this by dx. Isolating dx, it would be equal to du over 2x plus 1. Substituting that, it would be 2x plus 1 all over u, and dx right here would be equal to du over 2x plus 1. You can see it would cancel each other out, and you are left with du over u. Once again. And according again to the formula, it is just equal to ln of absolute value of u. This would be ln of absolute value of u. And our u here would be equal to this one. And now our answer here would be equal to 3 natural log of absolute value of u, which is x squared plus x plus 2. And for this third part, the integral of 1 over x squared plus x plus 2, if you try to use u substitution again, let u here be x squared plus x plus 2, and taking the derivative, which is 2x plus 1 multiplied by dx, and putting dx aside, this would be du over 2x plus 1. If you ever substituting this would be the integral of 1 over u and multiply by value of dx, which is du over 2x plus 1. Now you can see that it cannot be simplified because we still have 2x plus 1 here. It is not unlike in the second part earlier. So this cannot be used. And what we're going to do here is to use a different method. And so we can just focus on the denominator part, which is x squared plus x plus 2. What we're going to do here would be to complete the square method here. Whenever you're dealing with a completion of square, focus on the first two terms first, which is x squared plus x. In order to complete the square here, you must take the coefficient of the middle term, which is x, which is 1, and divide that by 2, and square it, which makes this equal to 1 over 4. And add and subtract that value, which makes this, let's just put this aside, which is x squared plus x, since this is the two terms that we have done earlier. And since what we have here would be 1/4, add this and subtract this and copy what's left, which is plus 2. And now you can see here, this term completes a perfect square. We can just rewrite this as x plus 1/2 raised to the power of 2, because whenever you expand this, you have the same answer. And just copy the rest, which is negative 1/4 plus 2. And by combining these two together, you would have a value of 7 over 4. No, just rewriting this. This would be x plus 1/2 squared plus 7 over 4. The reason that we want to do this would be to use the formula for this. Now, the reason that we would want to put this into this form, first up, we can think of this as x squared since it has a squared here, and since it has a variable of x, so just put that, plus 7 over 4, we can think of this as a squared since it is a constant, so just put it as a, because what we're going to do here is to use a formula from the inverse trigonometric. This should be the integral of du or dx all over x squared plus a squared would be equal to 1 over a multiplied by the inverse tangent multiplied by u or x over a, and just add constant of integration. So for this, x squared right here represents x plus 1/2 squared, and a squared represents 7 over 4. So for our answer, we need the value of just a and x, and so this would be x squared equal to x plus 1/2 squared, and by taking the square root of both sides, x here would be equal to x plus 1/2. This should be x, and for a here, a squared here is equal to 7 over 4, and taking the square root of both sides, this should be a equal to, we can think of this as square root of 7 over square root of 4, and we know that the square root of 4 is simply 2, and we can just put it as like this, a equal to square root of 7 over 2. Now that we have this, we can now replace this one. A here in this case would be equal to square root of 7 over 2, and x here would be equal to x plus 1/2 all over the value of a, which is square root of 7 over 2, and add plus c, which makes this your integral based on in here. So by rewriting this, this would be 1 over square root of 7 over 2, or we can put 2 on the top, which makes this 2 over square root of 7 multiplied by tangent or inverse tangent of x plus 1/2 over square root of 7 over 2 plus c. So let me just simplify this. I very apologize for my messy teaching, but I will improve soon. And so our final answer would be 2 natural log of x plus 3 plus 3 natural log of x squared plus x plus 2 minus 11 multiplied by 2 would be equal to 22, negative 22 all over square root of 7 multiplied by the inverse tangent of x plus 1/2, or we can actually put 2 on the numerator, which makes this 2 multiplied by x plus 1/2 over square root of 7. By distributing 2 in here, we have a value of 2x plus 1. And so, this would be your final answer based on your integral of 8x squared plus 12x minus 20 all over x plus 3 multiplied by x squared plus x plus 2 of dx.